This is 2018 AMC 12B problem number 22, and here is a view of this problem. P of x is a polynomial of degree at most 3. Let's go ahead and write it, I guess. Ax cubed plus bx squared plus cx plus d, whose coefficients come from this set. Oh, how nice. Where A, B, C, D, they come from that set 0, 1, 2, all the way up to 9. And here that also explains why our polynomial is of degree at most 3. Because if you pick A to be 0, then it's a quadratic, no longer a cubic. And furthermore, by the way, you can choose these in a repetitive way as well. So with replacement, so you are picking A, B, C, D randomly from this set with replacement, if you will. Well, obviously this is not a probability question, so but anyhow, so how many such polynomials satisfy this result, P of -1? Let's just plug in, right? So plug in -1 in this expression, we will have this. Let's go ahead and lay it down. And this whole thing is supposed to be equal to -9. So let's just arrange it carefully. So minus a plus b minus c plus d is equal to -9. And let's go ahead and move things around. So let's bring all the positive ones onto, say, the left-hand side, in which case we have b plus d plus 9 is equal to a plus c. And that's it. So where A, B, C, D are coming from this set, and how many solutions to this equation? That's it. So we translated this combo problem. First, it looked like an algebra. It had this algebra flavor, but now it's more like a simple casework type of problem, right? We can do our casework based on different things. You can do a casework based on the value of b plus d, or you can do it based on the value of a plus c. Either way actually works. Let's go ahead and try one of them. Let's say, for instance, if you do a casework based on b plus d, well, obviously b plus d, the lowest that you can get would be 0. How about the highest that b plus d can take as a value? Can I take b and d to be, let's say, 7 and 8? I don't think so, right? Because 7 plus 8 is 15, plus 9 is 24, and obviously the max that this one can get is really, if you pick both a and c to be 9, you will get 18. So in that sense, b and d, the max that b and d can take is really 9. Does that make sense? And that's it. These are all the cases that I need to consider. And let's go ahead and bash it out, I guess. Casework on b plus d. Well, b plus d is equal to 0. b plus d equals 0. Well, in that sense, how many different ways can I express and b and d, right? So there's only one way, right? So bd would have to be 0, 0. But how about A and C? Well, because BD is, they're both 0, they add up to 0. 0 plus 9, so we have 0 plus 9 is equal to A plus C. Now, that's a whole other story for AC. So, what about AC? Well, obviously, AC could be, 9 and 0, obviously, right? So, it can be 9 and 0, or it can be 8 and 1, and so on. Does that make sense? Or they can be all the way up to 0 and 9. And I believe there is 10 solutions in this case. So this was the first case. Oh boy, so there's a lot of bashing going on. Until we find a pattern, let's continue this way, and then maybe eventually life will be simpler. How about here? We can get either have 1, 0 or 0, 1. So we have really 2 values for BD. Obviously, in the previous case, because BD has only one choice, I was supposed to multiply, but so does that make sense? It doesn't have any effect. Here we have 2 choices for BD. How about AC? So because BD is 1, 1 plus 9 is 10, and that's A plus C. How many ways can I write AC? Well, in that case, well, the max for A is still 9. C has to be 1 in that case, and now so on. We go 8, 2, and so on. 7, 3, they should add up to 10, obviously, all the way up to 1, 9. And there's already there's only 9 ways to write these and 2 ways to write BD. We multiply them and we have 18 ways to so for picking A, B, C, and D, where obviously picking A and C and picking B and D are totally independent. Picking a value of A will affect the value for C. Picking the value for B will affect the value for D, but that's it. Does that make sense? All right, so now we are more or less with that observation. Actually, life is pretty cool. Actually, now I can start really thinking conceptually. So if B and D add up to 2, obviously this one is easy. So let me just continue using the same notation, I guess. 0, 2. We have really 3 ways. But how about the other one? So we have 2 plus we have BD, which is 2 plus 9. So the whole thing is 11, and that's supposed to be equal to A plus C. Now let's think about the value A. A can take any value from 0 to 9, right? And that's it. So how about the C? C is also in the same range. So what I'm trying to say is, for every value that I pick for A, there will be a unique value for C, right? Because it has to satisfy this. And because obviously, well, we need to rule out some cases here, because if A is 0, it won't work. A is 1 won't work. A is 2 would work, right? Because if A is 2, C is 9, and so on, all the way up to 9. So in that case, we have 8 solutions. So 8 times 3 would give us 24. And now we can do it much faster now. So let's just, now that we know what's going on, B plus D equals 3 has 4 solutions for BD, obviously. And when it comes to A plus C, it would be 3 plus 9, 12 is equal to A plus C. You will see that the potential values for A is just 3, starting from 3, 3 plus 9 is 12, all the way up to 9, which is how many more? 7 solutions. So 7 here, 4 here. We have 28 solutions here, and so on. So B plus D equals 4. That would give us 5 solutions for B and D, and A plus C in that case would be 13. So the range is really shrinking for A and C. We have 6 ways we can do it, so the product would be 30 ways. So the 6th case would be B plus D is equal to 5. In that case, we have, well, 6 ways, 6 solutions for B and D. And then how many ways to express A plus C equals 14? That would be only 5 ways, 5 solutions. So multiplying, so 6 ways here, 5 ways here, combined is 30 ways. 7, B plus D is equal to 6. 7 ways to write B and D. And then A plus C is obviously 15, which will give us only 4 ways. So combined, it will be 28 ways. B plus D is equal to 7, in which case we have 8 ways to express B and D. A plus C would be 16 in that case, and obviously the max it can be is 9, so therefore C has to start from, well, A has to start from 7 at least, huh? So there's only 3 ways in this case. So 3 times 8 is 24. Almost done. B plus D is 8. We have 9 ways to express B and D, and A plus C in that case is 17. Really, we have only 9 plus 8 or 8 plus 9, so we have only 2 ways here. So combined, there's 18 ways. And finally, B plus D is equal to 9, which there's only there is 10 ways, I should say, for B and D. For A plus C, it has to be 18, and there's really 1 way. A and B has to be A and C has to be 9 each. So 10 ways here. And finally, you can just add up all these numbers. So let's be careful here. The first case was 10, 18, 24. Let's list them. 10, 18, 24 so far. So we have 10 plus 18 plus 24 plus 28, 30, 30, 28, 30, 30, 28, 24, 28, 24, 18 and 10. And obviously we are kind of crossing our fingers, hoping that we haven't done any silly mistake along the way. So 30 plus 30 is just 60. I have another 20 here. We have 80 plus, and I have 28. 28 is just 56 plus 24 is another 80. We have 18 and 18 is 36 plus 24 is 60. And you add them up, so 160 plus 60, 220. So that solves this problem, quite lengthy, but most of the stuff we did was really redundant actually. We could have really simplified things if we have used at the least summation symbol, right? So which I should have done. So let's go back to this and let's see if we can how we can make use of the symbolism here, and especially the summation sign. So let me go ahead and probably use the green color here. So this thing here, the BD here, let's call it, say say K. So therefore A plus C is just 9 plus K here. So if B plus D is equal to K, where K ranges from 0 to 9, how many ways can we find B and D? How many ways can we solve it? So B plus D is equal to K, where both B and D, they are between 0 and 9, or if you will, they are between 0 and K, where because K itself is between 0 and 9. Does that make sense? And we want integer solutions. Obviously, there is K plus 1 solutions to this one. Does that make sense? So for this one, we have K plus 1 solutions. How about the other side? So A plus C must be 9 plus K. Yeah, so when it is 9 equal to A plus C is equal to 9 plus K, and obviously we know that K ranges from 0 to 9. When K is equal to 0, A plus C is 9, and we have 10 solutions. So starting from 10, when K is equal to 0, right? So let's list K equals to 0, number of solutions. Number of solutions is 10. When K is equal to 1, it's 10. A plus C is 10. And how many ways? It turns out we have only 9 ways, right? So so you can kind of guess that. And obviously when A plus C is equal to the max it can take is 18 when K is equal to 9, obviously. When K is equal to 9, in order to reach 18, you have only really one way to do it, and it is just it's just picking A and C to be both 9. So you can see the relationship, right? So when A plus C is equal to 9 plus K, there's really looks like there is 10 minus is it so? 10 minus K ways. Yes, 10 minus K, right? So that should make sense. So there's really 10 minus K ways. If you plug in these values into here, you will get these numbers. And that's it. So we have 10 minus K solutions here. And so now we can combine them into our summation sign, right? So the summation K equals from, we established it ranges from 0 to 9, B plus D, 0 to 9. We have, for picking B and D, we have K plus 1 solutions. And then we have 10 minus K solutions for A and C. And boom, that's it. This is quite standard. So this is just a 10 minus, or maybe I should say plus 10K, 9K I believe, minus K square in our range. And we can split it, obviously. K equals from 0 to 9, plus 9 times K equals from 0 to 9, K minus summation K square, K equals from 0 to 9. This one is repeating 10 times, so 10 times 10, plus this one is 9 times. So we are adding all the numbers from 0 through 9, including 0, so 9 times 10 over 2. And finally, we're subtracting sum of squares, which is just 9 times 10 times 9 times 2, 18 plus 1, 19 over 6. And that's it. That should easily give us the same answer, hopefully. So we have a 5 here. 9 times 9 is 81, times 5 is 405. Yeah, probably I won't want that, right? So there's a 3 here after I simplify, and then this one, there's another 3 here. Yeah, maybe I should have factored it out, but regardless. So we have 5 times 19, which is 190, 95. 95 times 3, 300, 285. Minus 285, which is what? 130. No, so again, I messed up. Not surprising, I guess. You guys are used to it by now. Did I mess up here? Hold on. I have 15 times 20 is 300, so this one is 285 for sure. So we have 81 times 5 is 405. Oh, this one is 120, silly me. Right. So this one is 120. 100 plus 120 is equal to 220. And that's it. Boom, we are done. We got the same answer as the long case, the case work, which was super bashy. If you check the AOPS discussion forums, you will also find some significantly faster solutions, almost like troll-looking solutions. And I would like to provide you one of them, actually. So remember our equation. So let's create a third solution here. Third solution. So remember our problem. 9 plus b plus d is equal to a plus c. Let's revert it back to what it used to look like when it had the minus sign. So we have a minus b plus c minus d. Well, where a, b, c, d are in this range. That's pretty cool. However, there's something, so it looks like a distribution problem that we are used to solve using the stars and bars type of arguments. However, these minus signs are bothering, but luckily look at the upper bound here, it's 9. So therefore we can come up with the following substitutions. So b prime, you can come up with a new variable as 9 minus b, and d is the other one, so d prime is 9 minus d. If b ranges from 0 through 9, b prime will also range from 0 through 9, and the same thing for d prime. If d ranges from 0 through 9, d prime will also range from 0 through 9. And boom, so when you substitute these, our problem becomes 9 equals a minus and 9 minus b prime plus c minus 9 minus d prime. So therefore 9 is equal to a minus minus, so b plus b prime plus c plus minus minus and d prime minus 18. So therefore our problem is transformed into 27 equals so 18, bring it to the other side, a plus b prime plus c plus d prime. That's not a convenient form, right? Because a through d ranges from 0 through 9, and it's not clear how I can get that. But what I can do is to think of the complementary problem. So let's go ahead and do that. So a prime now, let's define a prime as 9 minus a, b double prime as 9 minus b prime, c prime is 9 minus c, and d double prime is 9 minus d prime. I hope this one should clarify the problem. Now this is equal to 27 equals, we can replace a with 9 minus a prime. Right, and then plus 9 minus b prime is 9 minus b double prime plus 9 minus c prime. And finally plus 9 minus d double prime. Moving things around, now we have the good form. We can move the letters to the left hand side and this number 27 to the right hand side. So finally we have a prime plus b double prime plus c prime plus d double prime is equal to 36 minus 27, which is 9. Whew. And look at that. A prime, b double prime, c prime, d double prime again has the same features. They ranges from 0 through 9 as a, b, c, d did. So the number of solutions to this thing is the same as the number of solutions to this. But this is a simple distribution problem, right? Well, yeah, life is pretty easy here. We have 9 stars and we have 1, 2, 3 plus signs. So therefore we have 4 buckets. 4 boxes, you can say, split by 3 bars. So we have 9 stars and 3 bars. So therefore the number of solutions, non-negative solutions to this system, to this equation is 12 choose 9 plus 3 choose 3, which is 12 times 11 times 10 over 3 to 1 They move away. So do we have a 2 here? Again, 220 is the final answer. Hope you enjoyed the video and looking forward to see you guys in our next lecture.